Hello, this is Mrs. Taylor, and I'm going to go over number 10 from your Exponential Functions study guide. It says if a ball is dropped from a height of 24 feet, the function f of x equals 24 times 0.5 to the x power gives the height and feet of each bounce, where x is the bounce number. Graph the function using appropriate labels, units, and scales. So if they specify using appropriate labels, units, and scales, that is going to be part of the grade for the problem. So let's talk about what that means. Labels means the title of the graph, and labeling your y-axis and your x-axis is in context of a real-world problem. So you need to explain what part of this scenario is represented on the x-axis and the y-axis. So if you look, x is the bounce number. They tell you what the x represents. So on the x-axis, you can write bounce number. They also tell you that the function gives the height and feet of each bounce. So that is your y value. So this would be height of each bounce. And you have to be careful because remember it mentioned units. Units are your units of measure. So the height is measured, as it says up here, height in feet of each bounce. So we would say height of each bounce in feet. You have to specify your units as well. And then the last label is your title. So you could say height of the ball bounce. Okay? Now, the last thing listed is scales, and I think that's the one that students struggle the most to remember what that means. The scale is what you were counting by on the x or the y axis. So are you counting by ones, twos, threes? How many units does each line represent? Well, bounce is 1, 2, 3, 4. So our scale is just going to be 1. And because this is kind of small, I'm going to space it out. I'm going to skip a line in between my bounce numbers. So I have 1, 2, 3, 4, 5. So technically, if you think about it, the scale down here is actually 0.5 because each line represents a half a unit. Now, up here, I need to decide on a scale for my y values. Well, it starts at 24 feet. And if you think about a bouncy ball, each bounce gets shorter and shorter. That's confirmed by your common ratio of 0.5. 0.5, if it's between 0 and 1, is a decay. So it's decreasing. And remember, multiplying by 0.5 is the same as dividing by 2, which also helps you understand that your amount decreases. So 24 is going to be my highest number on my y-axis. And if you count all of these lines, it reaches higher than 24. So I can actually count by ones on the y-axis because I have enough lines to get to that initial height of 24. I'm not going to number everyone because I don't have space, but I'm going to number every 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So my scale on my x-axis is actually 0.5 because I wanted to space it out a little bit. And then the scale on my y-axis is 1. This would be 10, and this would be 20. It's really small. I know you can't read it really well in the video, but that's what it says. So one strategy for graphing is to build a table. And so I have my x values and my y values, and we are not going to include negatives because we don't have negative bounce numbers. So my x's will start at 0, 1, 2, 3, 4, 5. And if I wanted to, I could evaluate by substituting 0 in for x and evaluating that. Another way that's quicker, because we have access to our graphing calculators, is to let the calculator generate the table for me. So I'm going to enter my equation into y equals like that. And then I'm going to hit second table and let the calculator generate the values for me. So it goes 24, 12, 6, 3, 1.5, 0.75. And then all I have to do is plot those points on my graph. So 0, 24, 1, 2, 3, 4. And then we have 1, 12, 2, 6, 2, 3, 4, 5, 6, 3, 3, 1, 2, 3, 4, 1.5, and 5.75. Now, if you notice, my points definitely have that exponential curve. The question is, do I connect it or not? Well, think about it this way. If each of these points represents the height of a bounce, you have your first bounce, your second bounce, your third bounce. You have no bounces happening in between. So there can't be any values in between the third bounce and fourth bounce, because this point just represents the height of that bounce, not the height of the ball the entire time it's moving. So on this graph, I would not connect my points because there's nothing happening between each bounce number. You have your first bounce and your second bounce, and that's it. So that is how you would do number 10 on the study guide.